Alright, so let's have a look at the acidity of certain oxides. And basically where on the periodic table we can, or how we can predict the acidity or basicity of an oxide based on its position in the periodic table. So non-metal oxides tend to make acidic oxides. And what this means is that they will neutralize bases to make water. For example, if we mix sulfur dioxide with, which is a non-metal, with sodium hydroxide, which is a strong base, we will get sodium sulfate plus water, and that's neutralizing that strong base. Acidic oxides will react with water to form an acid, and this will turn litmus blue. So let's have a look. So if we mix our non-metal oxides, so sulfur dioxide again, with water, we'll get H2SO3. This is an acid, and that will turn litmus red. And this is actually a major component of acid rain. So if we now look at metal oxides, well, the opposite is true. They are going to make oxides which are basic. And this means that they will neutralize acids to make water. For example, if we add magnesium oxide to hydrochloric acid, you're going to get magnesium chloride and water. The basic oxides will react with water to form a base, so there's something with a hydroxide in there, and this will turn litmus blue. For example, magnesium oxide plus water gives you magnesium hydroxide. Now there are exceptions, obviously, because that's the way the world works. So carbon monoxide, now only carbon monoxide, carbon dioxide makes carbonic acid when it mixes with water. So carbon monoxide, nitric oxide, and dinitrogen oxide are poorly soluble. So they don't dissolve in H2O, and thus when they do, when they mix with it, they'll form a neutral mixture. So inert gases, so the noble gases, do not create oxides. And then there are the amphoteric ones. And the amphoteric ones are all labeled on this periodic table. So in the white we have our basic oxides, then we've got some neutral oxides over here. But see how there's also acidic oxides as well. These are our acidic oxides. These do not form oxides. And here we have our amphoteric oxides. And this means they can neutralize both strong bases and strong acids. And that's particular strong, not weak. It won't do the same thing. So, for example, if we could have aluminium oxide can be acidic. If we react it with sodium hydroxide, you'll get sodium aluminium oxide plus water, and that's neutralized it. But if we react it with hydrochloric acid, you get aluminium oxide plus hydrochloric acid, giving you aluminium chloride plus water, and thus neutralizing that. So let's have a look at it on the periodic table. The basic trend is from left to right. They go, also across the rows, it goes from basic, amphoteric, acidic. Remember, nonmetals are acidic oxides. The basic trend down is to go from acidic to amphoteric to basic. And what this actually means is, so as you go down the period, they less readily will form an acid. Okay, so these guys already start off fairly basic, so they're going to be much more basic and much more reactive with an acid as you go further down. Here, they're still acids. They're not amphoteric by the time you get down the bottom, but they're going to be more acidic up here. So there'll be stronger acids up here than they are down there. So the oxides up here, stronger acids than they are down here. And that's it. I hope that made a lot of sense. If you have any questions, feel free to ask them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. Bye now. See you next time.